Here we have a GraphQL server with a TypeScript type for our user. Then we have some type definitions for our GraphQL server. And then we have some static data for our users array. And then finally, we have the resolvers that map together the types to the users array to return those through the query, or we return a user object when we invoke the create user mutation. Then finally, we just invoke create server from GraphQL Yoga, and we pass it the schema, type definitions, and resolvers. If you've worked with GraphQL and building GraphQL APIs before, these type definitions probably look very familiar. However, there are a few things going on here that you probably should be aware of when designing your schema. So let's break this down line by line. Let's first look at the user's query. It returns a list of users, and we can see here with this special exclamation mark that inside of this list it returns the user type, and it will always return a list, and that's shown by the final exclamation mark after the array. This also means that no values inside of here can be null. We'll learn about lists and non-null in a further video. Then let's look at this user query. We have a user, then we have some arguments, and then we return the user type. You'll notice here that the argument ID is of the special type ID that is non-nullable. This means we can't call this query without passing an ID to the user query. If we switch over to GraphiQL and we try to run that query to fetch a user without passing an ID, we'll get an error from GraphQL. It's telling us that we need to pass an ID for our user. This might seem insignificant, but at this point, one of the special features of GraphQL is that it's able to validate against the schema what you send in, so it won't run any of your resolver code until those validations are good. Then if we pass in an ID for a user that exists, we'll get the data. So we'll fetch the first user, then the second, but if we pass in an ID for a user that doesn't exist, we will get the response null for our user query. Now let's explore updating the user query to return a non-null user. If we add the exclamation mark to the end here, and we go back, now if we run the query, we'll see here that we can't return null for a non-nullable field in our query user. This isn't the best developer experience, so what you'll probably look to do at this point is throw an error inside of your API so your API consumer users know exactly where the problem is, and in this case we could throw a better error here that says that the user cannot be found. Because I'm using GraphQL Yoga here, and it masks errors by default, I'll need to import GraphQL Yoga error so then I can call that inside of my query to fetch a user by ID. Let's change this so we can now return an error if a user does not exist. So first we'll assign user, and if there's no user, we'll go ahead and throw a new GraphQL Yoga error. And we'll fall through to the user if that user does exist. Now if we go back to GraphQL and we re-execute our query, we should now see that we have the error no user found. And that's returned to us through GraphQL Yoga because we use that special class. Now let's have a look at our create user mutation. We can see here that it takes in an input argument of the input type create user input that is non-nullable, and it returns a non-nullable user. If we inspect the create user input, we can see here that it expects a name of the non-nullable type string, and we have a favorite number, which is nullable. If we now move on over to GraphQL and we create a new mutation to create a user, and we don't pass in the name, but just the favorite number 10, if we execute this, we can see that we have an error from GraphQL telling us that the required type string was not provided for the field name. We can resolve this error by providing a name to our mutation. Now if we execute this, we can see that we have our new user. Now if we return null from our create user mutation, we'd get an error from GraphQL, and this is because we always expect there to be a user type that is non-null. So if we scroll down to our mutation for the create user, and we simply returned null, and we ran the same mutation inside of GraphQL, we'd get an error here that we cannot return null for a non-nullable field for the mutation create user. Now let's inspect the user type. We can see here the ID field has a non-nullable scalar type ID. Then we have the non-nullable scalar type string for our name. Then we have a nullable int field for our favorite number. If I remove the name field and value from the user's array, I'd instantly get feedback inside of my code editor that something is going wrong. And this is one of the built-in benefits of using something like TypeScript. If we remove the types for our server, and we save this, if we now go back to GraphiQL and we attempt to fetch all of our users, and we fetch their name, we can now see we cannot return null for the non-nullable field name on the user type. This would also happen if I updated name on both of the user objects, and we ran that same mutation. Null cannot be used instead of that field. If I remove the name or I replace the name value with null, if you're using something like TypeScript, this will give you instant feedback inside of your console to show that name is declared and it must be used instead of the object. Check out episode 26 where we use type-safe resolvers with the GraphQL code generator to make sure that all of our GraphQL resolvers are fully type-safe. So hopefully this video has given you enough support when designing your schema when using null and non-nullable fields.